Yeah, Chenyu is out this week. So I will lead the meeting. I'm not as good at it as Chenyu. Hang on. So yeah, we'll start with, instead of company general, we'll start with AMD contract general, because the main purpose of this company is the AMD contract. The AMD contract should be hopefully done to the best of our abilities by May. Look, we have 4 potential targets. We have a single machine one, a 2 machine one, and then if we can get anything, or if we can get faster than NVIDIA, and those are $400,000 each. I just want to show that TinyGrad can run the absolute best, train the absolute best models. If we're training Llama 405B, there's a few things big, of course, at the crazy labs. So I think it's a good target, and I think it stress tests a lot of pieces of TinyGrad in a way that's very important, because if you can train if you can start up the process that trains Llama 405B in a minute, you can start up the one that trains Llama 8B in 5 seconds. So all these things trickle down economics is real. So yeah, let's start with, I think the biggest thing holding us back right now from just actually training this stuff is flash attention.
A bunch of the stuff to implement flash attention is done. Currently on my branch, there's a flash attention forward that works on MI350. And then that's currently missing just GQA. Actually, GQA works now. And just the causal mask. And then I will write backwards this week and hoping to get something training before Thanksgiving weekend.
Great. Yeah, no, I think once we flash attention, we'll be able to train 8B. We can already train 8B now, but the time is crazy. Because we should kick off one with, you want to kick off one with 1024 context or something? Just to make sure everything works.
Yeah, that's fine. I had a week-long one going before, and it was fine. That was 1B 1024 though.
Let's check it again.
Yeah.
Can we do 8B 1024?
Yeah.
Yeah. Especially, let's do 8B 1024 8 GPUs.
Yeah.
I fixed MP, so that should work now.
Okay.
We should quickly benchmark them. But yeah, we should start always having training jobs running on one of our MI350 boxes. The other ones to play with. So yeah, that's that. All right, cool. So that'll be done this week. Let's talk about viz and profiling. So I see you got all the occupancies working.
Yep. Got all the occupancy stuff in there. It's pretty nice actually that we have all the SIMDs right there, and you can see the patterns of some things getting vacant.
Great. Yeah, I think we should probably set that SE mask thing to 0 by default. We have that SQTT SE mask.
Yeah, for the instruction ones. That will just disable instruction tracing on all of them.
No, I don't want to disable instruction tracing on all of them. We can keep instruction tracing on one. Well, actually, if we disable instruction tracing, is it really fast?
I think so, because the only thing that is tracing is the start and end of every wave.
Yeah.
I mean, it's fast. It's kind of fast even with instruction tracing if we do not limit any SCs. But there is a stage to copy out the buffer after each kernel. So actually, that will take some time.
Got it. I mean, I think what we should do for viz equals 2 is just make SQTT limit SE by default, not be on.
I see. You won't have any instruction tracing for that then. No instruction timings.
Any instruction tracing. Okay, so I just ran one and nothing is, it's broken in my counters view. Make sure I'm on the latest master. Yeah, I'm seeing nothing in my counters view. Oh, canvas exceeds max size.
That sounds weird.
Yeah, I'm in Firefox. But yeah, so I think the thing that I really want you to focus on this week is just starting to stress test this on bigger and bigger kernels, and on bigger and bigger. We have to get Llama 405B tracing with viz equals 2, basically. Like, that's the goal. SQTT limit SE is totally fine. We can leave that on. But yeah, let me see if Chrome has a better max size of a canvas. Oh, it does. Hey, look at that. But it's absurdly slow, and I mean, this isn't
We should
even
start
that
learning.
big of a kernel, and it's really slow. Okay, cool. But I like this intswave, awkwave. Yeah, and then we got to improve. So my parser is pretty good now. If you run with sqtt parse equals 1, I've figured out the whole format. I still haven't lined it up with the instructions, so I wouldn't use it quite yet. But just if you're like trying to figure out like actually what's going on and you're on like a small kernel, you can run it and it'll print it all out. It's pretty cool. But yeah, so I think when you're showing the like idle, duration, and stall, are those 3 numbers just given to you by the thing?
Yeah.
And does it give you how many if you're in a loop where an instruction runs 10 times, does it give you those numbers 10 times or 1 time?
10 times.
It gives you the numbers 10 times. Okay. So right now you're just literally copying in the entire trace, even if it's the same instruction over and over again. Yeah. Okay, cool.
Yeah.
Yeah. So if I do a search, so we got to fix that. What we should be doing is you have like the PC address of each of those instructions, right?
Yeah.
Yeah. So what we want to do, and if you read these in the profilers, is we want to show like a min, max, and an average if things are hit multiple times.
You want to show the sum?
Sum. Yeah, maybe the sum. Whatever the other one show. But yeah, I mean, these
RGB
traces
shows
are
the sum. Yeah.
cool. Yeah, the sum is good. These traces are absurdly long and unusable right now. Like maybe in the leftmost column, I want to see the number of hits. I mean, we should really just copy RGB.
Yeah.
Yeah, but right now with whenever you have a kernel with a loop, this is pretty much unusable because I'm not going to scroll through this huge, massive list. And it would be nice. I mean, what would be really cool actually is if there was a little triangle next to it and I could expand it, I could see all the hits of the instruction. But yeah, so I think good goals for this week are cleaning up the instruction trace to be that. We have to fix this. This profiler is way too slow, even in Chrome. And this is a pretty tiny kernel too. Like this doesn't have a lot of occupancy. Yeah, I'm getting like half an FPS. So yeah, what do you think that is?
Oh, the slowness?
Yeah. Are you experiencing it too,
In
or is it?
my rendering is pretty naive. It's rendering every single thing, even if it's not in the view.
No, but that's not even the problem. Like on this kernel, I don't really know why this is that slow. I mean, we also have to make it thinner, smaller. I really do want to fit the whole GPU on a single screen.
Yeah. I tried. At some point, it gets so small that you see nothing.
Yeah. I mean, let's think about how we can do this. Maybe we should talk about this more after the meeting. Yeah, I have a lot of I think there's so much capability here to go like beyond what the existing GPU profilers have done. But first, let's meet the existing GPU profilers where they are. Yeah, and I'll change SQTT limit SE to be 0 by default. So that's pretty nice. I mean, yeah, this is beautiful. Like, it's so beautiful that we can see, like, I really like the way the inst waves are lit up differently from the awk waves. Oh yeah, why have we still not added where I can double click on an inst wave? Is this hard?
I'll add it. No, I'll add it. I just didn't spend time on it. So.
Okay, cool. I mean, I've asked for it a whole bunch of times, and I feel like when I'm asking for something a bunch of times, there's a reason it's like subtly hard, and
No, just work on other things. I'll do that.
okay, cool.
Yeah.
Yeah, so double click on an inst wave, then I can go to the instructions, and then the instructions have to be like deduped. There should be at most one line per instruction. Not per hit of the instruction, but per like PC of the instruction.
Yeah, makes sense.
Actually, that'd be kind of cool too, to just put the PC, not like the whole PC, but just like the offset from the top. My new fun weekend project, since my tracer's kind of done, has been to start on an assembly dialect, like an assembly DSL. And I have this really nice assembly DSL where you'll be able to pretty much just write the assembly instructions in Python, but as functions, which will be kind of nice. But yeah, no, this is shaping up to be a very good GPU tracer. It's all pretty easy to use now too. I put a lot of work into like I put the power thing automatically in viz equals 2. I mean, viz equals 2 should basically just work everywhere viz does, and we just accept that there's a little bit more overhead. Yeah, I don't think we need the SQTT limit thing. I think that's only if you really want to trace like a tiny kernel, but we should be just tracing the whole kernel, and you get whatever waves you get. It's nice when you can like see the occupancy. Whoa. Oh yeah, this has to be a lot faster. Also, can you, by default on the Zoom, can you not start it at 0?
At the clock that it starts doing instruction execution?
Yeah, just at the first clock that we have anything for. We can do that on the main profiler too, right? If the thing just sits idle for 10 seconds, and then does something, and you should be able to zoom out to get to 0. Like if I zoom back on the wheel, I'm just saying the default zoom should be the same way you have the max of the default zoom be the end of the last kernel. The min of the default zoom should be the start of the first kernel.
Yeah. But you can scroll back. That makes sense.
Great. Yeah. Double click, speed, instruction deduping. Yeah, this is turning into a great GPU profiler. I mean, you can go. Did you try SQTT trace equals 1 at all?
Your decoder?
Yeah.
I got asserts that some fields should be 0, but wasn't 0.
Oh, I think I fixed that. Try now.
Okay, I'll try again.
See if it works for you.
I think I tried Saturday night, so maybe it's fixed.
Yeah, I fixed a bunch of things. Well, I fixed a bunch of things Saturday, but why didn't that work? Is it SQTT trace? What did I name it? Oh, SQTT parse. Oh God. Too many flags. Yeah, I added 2 new counters to the thing where we count the number of flags and the number of ops, and I want them both to go down. Yeah. SQT like this line works. I added like pretty colors to them and stuff. So if you, it shows you when the instruction gets enqueued and then when the instruction executes for ALU and memory instructions. And then there's another class of instructions called immediate, which is and then yeah, there's a bunch of it shows you all the wave starts and wave ends and stuff. So it's pretty cool. Great. Cool. Yeah, I think we got stuff for that. But so yeah, is everything clear? Is there anything I can clear up about like the instruction deduping or the speed of the stuff?
I think this stuff is clear.
Great. NVIDIA HVAC decode.
Yeah. So it works. So right, I just implemented a custom parser of the file format because we need some fields which we cannot get from. So like hardware needs them.
Which is
Ye-
interesting. Because when you use the NVIDIA API, how does it get that stuff?
I mean, you just parse, you just feed the whole file into the qubit. So I
Really?
think they just, yeah.
I don't remember requiring that, but I'm probably wrong.
I mean, basically they need this because like all these headers, they just have different sizes dependent on the features, and actually even numbers are like encoded the way that they, dependent on the value they had, they can have different sizes. So
Got it.
yeah, and actually hardware needs to know how many beats it needs to skip for such things. Because
Cool.
yeah,
Yeah, no, I
yeah.
mean, the way that we use this at Comma is we have this stage called vidindex, which extracts all the GOPs from all the HVACs, like in Comma's files. And then in order to decode for training, we just shove the GOPs into the decoder. But I guess that works because they all have the same like format.
Yeah.
There's a crazy amount of flags here.
Yeah, it's so yeah, actually it works. I know I can just try on
Oh,
Commas
are
videos.
these flags per frame or are these flags per video stream?
Like some of them, like PPC and SPC are just per video stream. And there are also some amount of flags per frame.
I see.
Yeah.
Cool. Okay, yeah, and then let's talk about the front end thing. So I see you added an op called AnkDAC.
Mm-hmm.
Yeah, that's probably the right way to do it. I mean, how does that like become a kernel and stuff?
I
Like,
mean,
what is
it's
the?
Hmm?
Oh, sorry. Go ahead.
Yeah, I mean, actually, so what we need to decode each frame is like, basically we need to know the history and the current state. So and actually that's what I just try to pass to the runtimes. So yeah, so AnkDAC is going to have several like inputs, which is like the history and the context as an argument. So yeah.
Got it. Yeah. So is it going to kind of look like copy, like the way that we use the copy engine? I mean, I'm just thinking of like
Yeah.
like what the abstraction of this is going to look like. So like on the low level, do you submit it to the stators or the same queue as the copies or a new queue entirely?
No, it's completely different queue, and NVIDIA, like the CUDA library, doesn't. So actually, they don't set up like the UVM to this engine, and I couldn't make it work with the UVM.
The
So
UVM.
I
Do we
mean,
use the UVM?
yeah, I mean it's for P2P. So
The
basically,
P
this engine
wait,
can
wait, wait, wait,
currently
wait.
see.
The P2P thing doesn't use UVM. The P2P thing just shoves the page table, just shoves the other address in the page table. I don't
I mean,
really know what UVM is.
I mean that's kind of their implementation of like unified virtual memory, and actually it just manages all tables across all GPUs.
Yeah, my understanding of UVM always was that it was something that lives in the kernel that like intercepts writes to the GPU memory and then like, moves them and stuff if you have like small bar or something. Like UVM lets you effectively map your whole GPU even if you have small bar. But I'm not sure it's UVM if you're using it right on the GPU, right? Like the way that we do P2P, like I wrote that P2P driver, we just shove the other address in the page table. So what specifically are you saying?
But actually, that was part of the UVM. I mean, of the
That's part of
UVM
UVM,
module. Yeah. I mean, basically, it's better to say like that, like, I couldn't make this engine work with the like virtual address space.
Got it.
So when I just
So you're
add
telling
these
me
arguments,
you're basically telling me the engine works at a lower level than the GMMU, and you have to put the physical address of the GPU memory in there.
no, I mean, actually, I think it will be clear for me then I just implement these for like our driver, and I'll just see what it's actually accessing underneath. But I mean, it's just throws an error now. Like the GSP throws an error if you just try to allocate this engine with the virtual address space set.
Got it. But so you have to give it a physical address space.
No, you kind of allocate another virtual memory, and you just
I see.
and you just map it there. But this is virtual like memory is not managed by UVM. So actually,
I see. I'm reading the code here. You're doing this UVM create external range. So it's like an IOMMU kind of.
Yeah. So, and because of that, the only limitation is that this engine in the current implementation cannot access like P2P memory of other GPUs.
That seems okay.
Yeah, but yeah, maybe that's fixable. I need to implement this for our driver and see.
Yeah, but even if
I
it's
just
not,
tried.
that doesn't seem like a big deal. We can just add a rewrite rule that, right, like it has to be on your device. I think it's totally fine. But I see. So it's in a totally different FIFO. It's in this NV video queue thing, which is like, yeah, okay, perfect. NV compute queue, NV copy queue, NV video queue. That's great. We probably, unless it's really fast, we probably also don't want to build a video queue unless you use it, but I'm worried about that later. Like, can we move these setup GP FIFOs to like on the fly?
What do you mean? I mean, like,
Well, right now, if I open an NVIDIA GPU, I'm going to create a video queue every time, right?
oh yeah, I mean that's pretty fast. But we can, of course, like lazy allocations, but it's pretty fast.
Got it. Yeah, no, I'm just saying, like, we kind of need to like abstract these things like into something, right? Like copy is this thing that like uses the copy engine. I think we almost want like a UOP for that, like an engine UOP that says this doesn't use the normal. I don't know exactly what the abstraction is going to be like, but not that worried about that. Cool.
So
Okay.
yeah, I mean, actually, the only thing is like to finish that is to somehow make these like to make this state hashable, because currently it's not hashable, and I'm just really afraid that it will take a lot of lines if I just create the frozen like the frozen data, how it's called,
To make it so you mean like
data class. Yeah, because I need to pass it.
Yes.
Yeah, so I'll think about this, how to make it. Yeah,
Got it.
it's actually it's a lot of data you need to fit into GPU to decode each frame. So
Yeah, seriously, I'm staring at it right now. And also everybody else can see what's being discussed. But cool. All right, seems like good progress on this week. When HVAC decode is in. Have you looked at all into the SIP-free macOS stuff?
No. Yeah, I can look into that, but
I'm mad at Apple for doing this too, but like you see how many these things get so many likes on Twitter. Like so many people are excited about eGPU. And I think that 80% of people won't turn off SIP to try it. So yeah, it's worth putting some time in if it's something that's going to be very easy to maintain. We also should just improve like the packaging quality of that, right? Because like right now, in order to install that driver, you have to know about the special thing in extra. You have to know that you have to disable SIP. You have to go in there, build this project. You need Xcode on your Mac. And yeah, and then you install this thing. You get very little feedback if it works. Otherwise, it just throws an error saying IO open failed. So many people, every single person who's tried to use this sets AMD iFace equal to USB and not PCI, which is just like, a little foot gun, right? Oh, it's plugged into the USB port. Well, the USB port, PCI, blah, blah, blah. But yeah, no, I think we can. I think it's worth putting some effort into like improving the overall packaging of this. And then, I mean, hopefully without SIP, what we can do is we can create the context. Like the only thing we should have to do, hopefully, is IO service open in the sign process.
yeah.
Yeah, and then do like mock port send. Take that, Apple. But cool, yeah, I think it's worth putting a bit of time into. And then also the bug that Chen Yu hit on the 350.
No IDs yet. I'll
No
take
IDs
a
yet.
look.
Cool. Yeah, no, he said it worked with hip equals 1. So cool. Anything else?
No.
Yeah, go work on the decoder. Are we really gonna put in 12 megabytes of Big Bunk Bunny in the PR? You guys wanna play along at home? Yeah, we should definitely have tests for this. It's good. We should have tests in the benchmark. And yeah, commas HVACs should be pretty much like there's tons of places that have comma HVACs we should just test it on. But we should also probably test on like 10 different HVACs to make sure we got all those things right. Cool. All right, Qualcomm Mesa backend.
Yeah, that's pretty much ready to click merge. I mean, unless there's something that comes up in this meeting, I was going to click merge on it when this is done. But yeah, it's great that we have a fully open source stack for that whole backend. I'm trying to think what's sort of major that also has changed in this thing.
Wait, where's the
one
PR?
thing? Oh yeah, let me. Let's see here. But
This one.
You need to change your default sort to sort by updated. I don't know if GitHub sorts by authored date by default.
Oh, I see. Okay. Sorry, my bad. All right, I'm looking at it.
yeah. Yeah, so one of the things that this adds, it bumps the Tiny Mesa version and also the Mesa version, but I mean that should be fine. All the CI passed, and it's just like it's not even a minor version update. It's a patch version update, so I think it's fine. Yeah, the big thing that this changes that might mess some people up, so it's worth saying here, is that the disassembler for the Qualcomm CL backend now uses Tiny Mesa to disassemble. So it won't cause any problems unless you run with debug equals 7, or I guess it will if you run in Viz and you click on disassemble. But yeah, if you're running into errors trying to disassemble stuff on the Qualcomm CL backend, it's because you need Tiny Mesa.
Yeah, and hopefully, does it have an error that tells you that?
It should. I haven't tested it. I can test it. But yeah. I mean, I think in general, like we need to fix the error handling for all of the like library dependencies. And hopefully we can just unify all of that stuff because otherwise we're just gonna have like 10 copies of that for every library that we import. Yeah. What else? There's one other thing I was gonna say. Oh yeah.
Do you know about update benchmark, by the way?
Oh yeah, I do. But there. Okay, I didn't. This PR doesn't have any benchmarks set up in it. I was going to do that maybe in a separate PR, but I can do that in this PR.
Oh, I'm not talking about adding benchmarks in this PR. I'm just talking about making sure that the other Qualcomm is not broken, so that you push it to update benchmark before you merge the PR.
Oh yeah, that's for sure. I will do that.
I see here that it's setting ISA mode to ISA mode GL instead of ISA mode CL.
That is correct. That's a side effect of the fact that Mesa is a GL compiler and not a CL compiler. I mean, yeah.
Oh, do we also have a final verdict on the speed?
Yeah, I mean, I sent that screenshot in Qualcomm hardware. So you can compare that. That's like actually a valid comparison now because it's half instead of float 3 shoot like it was before. But yeah, that's the image stuff running, and then the one you sent is the stuff in CI running with the CL backend. So it's faster on some stuff. It's not faster on everything.
Yeah, it's a little confusing in that screenshot because like this first kernel is at a very different time. Like the kernels that are before the JIT cache. I mean, I'm curious what it like says total for the runtime of the vision model. Is the total runtime of the vision?
Yeah, I have to SSH into that Tiny C3 right now. So I don't have that right now, but I can pull it up. I'll send that in Qualcomm hardware. But if I remember correctly, it was like right that the right now the full model runs in like 16 milliseconds or something like that. Is that right? Does that sound right?
I think it's 16 on. Yeah. But I'm just curious which one's faster. I mean, the real thing to do here.
The Qualcomm the existing one was definitely faster, but it was faster by like 2 milliseconds or something like that.
Got it. Yeah. So the right thing to do here is to get it running in benchmark, but you're welcome to merge the PR beforehand.
Mm-hmm. Yeah, the thing that I'm worried about running it in benchmark is that stupid race condition in the Onyx loader, or whatever it is. I don't know if it's race condition or a memory corruption or what. So I was worried that it was going to be super flaky. So I got to figure out what that bug is before I can add the benchmark.
It's crazy. It's crazy that how can that be affected by the back end at all? Or do you think it's always there and it just doesn't hit as much?
I mean, I have no idea, but it doesn't make any sense to me because like the error is in like NN Onyx, I'm pretty sure. And it's a reshape. Like it's trying to reshape to 0. Like it's just trying to do an invalid reshape, which like I don't even understand how that could possibly be affected by the backend. So I have no theory of why. Yeah, exactly.
Memory corruption, use after free. That's what that sounds like.
Something like that. I just remember the one other thing I wanted to mention is that the null backend now has the secondary role. So right now, or previously, was only used for the emulate stuff, but I also wanted to add it as a compile only backend. So the idea being that you could set like null equals 1 and then null underscore IR3 equals 1, and then that will it'll just compile your code. So it'll run the renderer and it'll run the compiler, but then it won't try and run your code. And the idea is that we could put basically we could put everything into CI, or pretty much everything into CI. And like there's no Qualcomm chips in CI, obviously, but we could be verifying that like that your stuff actually compiles and hopefully catch a lot more bugs. So this is that testing for Qualcomm, but I think it would be it should be a relatively quick process to just add everything. Obviously we can't do CL, but
I see here how you did it. That looks great. It's totally reasonable to me.
Are there other tests that I should run? Not just test ops?
Well, yeah, you should run the whole test suite.
Okay, sure. Yeah, okay.
I mean, run the whole test suite. It probably all doesn't pass. It probably all doesn't pass backend either. But if there's any like,
well, the nice thing about test ops is that it was super easy to just go in like right?
Wait, you glitched out for a second. I heard
Oh,
up to
sorry.
test ops. The super easy thing
yeah,
about
yeah, so
test ops was
Yeah, the super easy thing about test ops was that it was super easy to go in and just put a return right in front of the compare, like the search all close, because they all use helper test op. Like they all use helper test op, and that does
Oh,
it.
that's what you mean. Oh, you're talking about CI. Oh, I wouldn't worry about that. I think test ops is more than enough for testing the compiler.
Okay, yeah, okay, yeah.
Yeah. That's good. Yeah, if you can check with the
The other
backend,
thing,
just how to do that. Yeah.
the other thing that's worth adding that isn't in there right now is probably doing an image equals 2 on the test ops. So you run one with image equals 2 and one without.
That seems good.
Yeah.
Yeah, I mean, eventually we want to separate tests into like tests that require hardware and tests that don't require hardware, and yeah, there's a lot of work to do here. To like better tighten our abstraction layers so we can like, yeah, this all runs in CI. I mean, this is one of the huge wins of LLVM and like projects like this in general, whereas you don't need the hardware actually to compile for it. And there's no reason that you should. I mean, this is like the failure of the OpenCL API. But yeah.
Yeah.
Cool.
Yeah. Yeah. So if there's anything, if there's not anything that I think we'll click merge on this after the meeting.
But yeah, it looks good to merge as long as benchmark's passing. And then I think the next thing to do is to add this to benchmark and then figure out how we can get more speed. Speed.
Yep. Sounds good.
Cool. Speaking of speed, Python speed. So yeah, I think this is going to be my project for the week. We made Chinyu worked on this a whole bunch last week too. I think we've made pretty good progress. I think everything's like twice as fast. I think that it seems about like every week you work on it, you can get another 2x. So that seems about. Wait, what were you saying about the Onyx thing? Did you have an idea?
It might be backend related because I think Onyx, if it does any conversions from disk, it will go through the backend.
Oh,
Oh, interesting. Maybe.
Onyx.
Okay, I'll have to look at the types. That might explain it.
Can we just force that to CPU?
Yeah, maybe it already does this.
I could very well believe that it doesn't.
Yeah.
Yeah, that there's some like contiguous and it's like making this little kernel. Yeah, and then it's like, but that's interesting also. It seems like it surfaces a bug in the back end.
Yeah.
But that explains why it could be broken. Yeah, if you're like reading from disk and you're
But
doing
it's
like,
doing the conversions because it knows the backend doesn't support the type, but then it's using the backend to, right?
that I don't know. But
okay.
yeah, I mean, yeah, run with debug equals 4 and see if Onyx is actually like creating kernels.
Yeah.
Yeah, I mean, this could also potentially be with Qualcomm in particular. I'm worried about cache invalidation bugs. If we're not properly invalidating the cache, there's a chance you're like creating something, the GPU's copying it, but that's hanging out in because the Qualcomm has a different L2 cache for each like subsystem. So the Qualcomm has 3 L2 caches: the big island, the little island, and the GPU, and the DSP has one too. So there's 4. So yeah, I worry it's something like that. But yeah, no, good idea. That's probably what it is.
You think I should just force that to CPU? I mean, I can see what the errors are, but if it's like
no, I think we should figure out what the errors are and not force it to CPU. I think we should figure out who's ever working on Onyx should figure out how to force CPU more generally. This is just there's a lot of bugs like this around a disk too. But yeah, no, this is definitely just surfacing a bug in the back end. That's probably a cache invalidation bug, and that's why it's flaky. That makes a lot of sense to me. So it's a failing test or a gift.
Yep.
Yeah. So yeah, Python speed. That's what I'm going to work on this week. Scan would be great, but I don't think we need it for this. And scan is no excuse for not making the other thing fast anyway. We have the VMAP story is much better now. I really cleaned up the VMAP story where you can use shrink and then the derivative of shrink is pad. So we can do derivatives on VMAPs mostly. There's a few annoyances. One of the things that probably I need to do first is get string ranges supported, because like if you have a range in the forward pass, like range 0, you need to create a corresponding range in the backward pass. It'd be nice to just call that like 0_grad, right? Because like if you're looping through on the forward, you're gonna have to loop through on the backward, and that's the creation of a new range. So then what do you call that range? So this is why, yeah, Halide and TVM both use strings. So we should move the ranges to strings. The problem with moving the ranges to strings is that you then have to think about what your range priority order is. So currently we sort the args of the ranges, and that determines range priority. But that story needs to be cleaned up too. So that's my real job. That's the kind of stuff I'm going to work on this week. Yeah, and get it to the point where we're reasonably, I think that a minute startup time for 405B is totally reasonable. It's going to be a 11-day training job anyway, so a minute is fine. But yeah, we should be able to test quickly. We can test with a smaller number of layers. Even a couple minutes is probably fine. 10 minutes is a little much. You don't want to wait 10 minutes to find out you have a bug. But yeah, Python speed. Yeah, and then my other weekend project, you can check out my PR for that. It's just called Having Fun with Python ASM DSL. So yeah, as we move to, we're going to want to start putting assemblers into Tinygrad. And this is just stuff with making like all the bit fields really nice. So you can see my my instruction encodings are pretty much as beautiful as you can make a DSL. And then it's going to support things like this to like create an instruction. So that's like, the instruction, and all those helpers are going to be auto-genned. I'm going to extract all these enums. It's going to be like as auto-genned as possible to get you the cleanest DSL. Those classes are as copied as I possibly. So it would be nice to have. Yeah, how much assembly do you think we're going to have to do for?
It's just forcing.
Yeah, I mean, I think we start with doing the custom thing and see how does.
No custom, because I don't see how I can specify register from custom. Like, how do I link a UART to register?
How does Thunderkins do it?
Well, they're just in C++, like in ASM volatile, and they can just pass in the variable.
You can ASM volatile with a custom instruction too.
Yeah, but what's the variable name?
Parentheses 0. It's like a little templating language.
No, yeah, I know for ASM volatile, but
No. It's the same in custom.
Variable.
It's the same in custom.
Oh, really?
Yeah. It has a little you can pass in args to the custom, and they just show up as like.
Oh.
You read the and if it doesn't support that, you're welcome to add it. But it's the same sort of templating language. So you can totally, you can like pass in a thing, and then however that thing is going to be rendered.
I see.
Is how it's passed into custom, and custom will do that replace for you at the end. I mean, a custom would be pretty useless if you couldn't pass in variables. So all that should work. I mean, we should just make custom work to get our inline assembly working, and then we can like tell this. We can start transitioning to an assembly much more gradually. For assembly, we need a bunch of things first. We still need. I don't know if someone wants to work on this. So we have this memory planner that we run in the big graph for globals, but we need basically that same memory planner. We can do it right now for locals. Right? This is already a thing in AutoGen Flash Attention, where it creates 3 locals, but they're never used at the same time. So all 3 of those locals can actually just be one local. You just have to like look at like the def use and the the liveness analysis. But yeah, no, I mean, that should be unified with the memory planner. And then the story for registers, I think, is pretty good. So we have this op called define reg. Define reg is used if you need to basically do a back reference to the register. If you're using that register as an accumulator, you have to do it explicitly with define reg. And I actually like this better than LLVM's fee instruction. You can do the same thing in LLVM too, but LLVM has this fee instruction where they pass it through. Actually, I guess you can do the other thing in LLVM too. So, and this is actually how we generate the LLVM. So yeah, when you define reg, that's just going to be pre-allocated in specific registers. Again, you can do that exact same liveness analysis that you do in the locals to see if these big chunks are non-overlapping. But those will be the first registers allocated. The registers that you use for your accumulator. On CDNA, we can use the AGPRs. So CDNA has these special accumulator GPRs if your output is from a WAMA, which is pretty cool. Yeah. So you'll assign those registers, and then I think even a very naive register allocator would work pretty well for GPUs. I think that register allocation on CPUs is a much more constrained problem than register allocation on GPUs. Register allocation on a CPU, you just have a lot less registers. I mean, GPUs, it kind of matters for warp occupancy, but I think the more difficult thing about assembly is not going to be the register allocator. It's going to be cleaning up symbolic. So right now in symbolic, we pay very little attention to, like, if you're doing A+3, right? So let's say you have like a range A and you do A+3. Well, where should you do the A+3? Should you do the A+3 at the top and keep around 2 registers? Or +3 right when you need it? But it's that exact same trade-off that you have in every other part of GPUs, which is, do you want to recompute or do you want to store? It's the same problems. It's the same problems at every single layer of this abstraction hierarchy. It's just a question of actually doing it. So, yeah, I think that by the end of next year, we're going to have some serious non-LLVM backends, some completely full TinyGrad, all the way to GPU assembly. And I think GPUs are the place to do it, especially when you look at the MI350 and you see that LLVM is not that good. The LLVM backend for the MI350 makes all these ridiculous mistakes when you look at the code. And that's why the Thunder Kittens people needed to go to assembly for that. The NVIDIA does not do this. The NVIDIA compiler is a lot better. Even like, it seems like mostly a CDNA 4 problem. The 3 one looks better too. The MI3, I don't know what they broke. Like the MI300 code looks better, but
Maybe LLVM equals 1 also just doesn't work on 3. It like crashes on a bunch of simple things.
well, that's a different. Oh, that's probably because we don't have the latest version of LLVM.
I bumped it to 21 and it still doesn't work. I thought it was LLVM version.
Then they didn't upstream them.
Yeah, I was. It just there's some changes that aren't in 21 yet.
Yeah, probably because they're janky, and the LLVM people told them no, and they're like, no, we just hack it for this one thing. Okay, there's your problem. Yeah, so it's TinyGrad needs to eventually replace LVM anyway, but we shouldn't really do this until we have a very good story around all of these. The register allocator, in many ways, is the memory allocator, and then things about symbolic, like it really starts to matter because we don't have this extra compiler stage. You can give Clang crap. You can tell Clang, B equals A plus 6 plus 3. And Clang will happily turn that into A+9 for you. Whereas if we get rid of that, even in PTX, the lower level will clean all that stuff up for you. But if we get rid of that, if we go right to assembly, we better make sure we have a really good story around that. There's also tons of SGPRs. I think SGPRs are underutilized. If you read that RDNA3 mapmol, he's like, I just used a lot of SGPRs. And SGPRs are totally free. I believe. Like, I don't know if do you ever run into warp occupancy issues with SGPRs? Do you know?
I don't think so.
Yeah, I mean, it's not like that big. Why would they not like put tons of? They'd probably want to do SGPRs that are big enough for your full warp occupancy. So, yeah, I mean, it seems like these things can support like 16 or 32, depending on how you count it. So, yeah, if there's enough SGPRs, then you never have to worry about SGPR pressure. You should happily use them all. Yeah, I was looking at the encodings this weekend and the RDNA3 stuff, and they look cool. All right, cool. We got 10 minutes. I see there's a PR for me to review on WebGPU. Hopefully I can just click merge. Again, the amount of talk of WebGPU versus actual web. Okay, good. This one looks good. Assert where test models, test whisper, passing CI. Great, merged. Cool. I also went through all the PRs, so there's only 2 pages of them now, which is nice. You can't really get less than 2 pages, but 2 pages is pretty good. How many people we have working on this? SQTT instruction timeline. Oh, this is pretty. I didn't see this one. Yeah, I mean, we also want to think about, I mean, then first we got to speed up the thing, but like once we have warp instructions, we can start showing where stalls are. All right, because the stall is like when are you, I mean, this is the right idea. We want to basically show the utilization of each GPU resource. And then you can see where you're getting bubbles and where you're getting non-utilized GPUs. So yeah, this is cool. This is definitely the right direction to go in here. Yeah, I mean, like that's crazy because that's like not even per warp anymore. You just have like it would be per CU. You want to show what your utilization of all the different resources in the CU is. So
Even
yeah,
super SIMD, I think,
yeah, that's
because the
well.
SIMD can context switch and
So
hide
per sim,
latency.
I mean, I think a SIMD is just like an ALU. So I think you'd want to like show both SIMDs on the CU. But does each SIMD have its own load path? I don't think they do.
Uh, they do share. I think CU is like 2 SIMDs.
So yeah, I mean
Right.
so I would imagine for the CU you want to show something like your memory path utilization and then your ALU SIMD 0, ALU SIMD 1, ALU SIMD 2, ALU SIMD 3 utilization. You can really like it's really cool with that SQTT parse. It shows you like what the GPU is actually doing. I don't know. To be fair, I didn't look at the output from RockM Trace Decoder that much. I'm sure it's all there too. But like for me, it's just a lot easier for me to like understand stuff when like the hardware is giving me something because I can see how this was actually implemented and not going through 100,000 lines. God knows what.
God knows what's going on in there.
You know what?
Yeah, God knows what's going on in there. I mean, I would love to actually just upstream the SQTT parser and put it
Yeah, yeah.
more stuff.
I think we will. If you're excited about that, yeah, we have to do a few. I think we have to do a few performance optimizations on that. It's like written really naively. I vibe coded it. That's why it's an extra. Oh my God! Like you start reading any code that ChatGPT actually wrote, and you're like, "This is terrible. This is so bad. Like, why did you write this?" You know, like it all looks good from like a glance if you're not reading it that carefully. But as soon as you do like close readings of any GPT code, you're like, eh, GPT lacks taste. Yeah, okay. If you're excited about upstreaming that, I can work on it more, get it matching the instructions, and get it faster. I don't know. It was kind of easier than I thought. But yeah, no. I mean, do you feel blocked at all by the RockM thing?
I don't think so. It's pretty
Yeah.
nice. Alright.
If you're not blocked on it, then it'll stay the weekend project. I don't know. I'm a lot more excited about working on that than I am about working on Python speed, but you know, Python speed is what we need. And I'm more excited about Python speed than I am about working on excited than I am about working on scan. Scan is hard. Like like edge cases and like what if you scan and assign? Oh. Yeah, but cool. Yeah, no, I'll keep that the weekend project and I think for assembly, I think for now we can just use the custom inline and it's all pretty good. Cool. Let's quickly see if there's any other bounties. How's the GPT OSS one coming? I know we got a locked bounty on that. I see the tests failing on the Winograd one too. Okay, Olmo is running fast. How fast is GPT OSS running? Yeah, but we were at 0.1 tokens. All right, so 1000x off, but it's faster now. Haven't worked on it this week. Okay, cool. Yeah, we gotta get some more speed on that. I don't. Why is it different from Olmo? Is there any reason it's like harder to make fast than Olmo? I see, some like softmax thing. Olmo only works for batch size of 1. Oh, I don't care if this only works for batch size of 1 too. That's fine. The only thing people care about is batch size of 1. I was imagining making a really similar GPTOSS is an extra scatter operation. All right, I'll think more about that later. But like once we have that merged, I want to merge like a 100 line web UI, and I want like Tinygrad apps LVM to like reuse the infrastructure from Viz to make it. But no one should work on this. It's just something that like the Tinygrad should be pip install Tinygrad. Python -m Tinygrad apps LLM, and it opens this web interface that has 0 dependencies that runs an LLM. I think that would be another way to get users. Okay, HVAC. Oh, I saw a PR for the refactor multi. Yeah, you have to don't apply tensor map. Don't use UOP map. Right, like that PR was clever, but not what the bounty was about. Like, I don't want to use that like map graph thing anymore. It's kind of like low quality. Like multi should just be a part of everything else and should be processed the same. Yeah, the Python time one. Haven't seen any PRs for that. Oh, the T-flop gem, that should be so easy now. Someone can totally just do that. It's like practically copy paste. $300 copy paste. Works over USB 3.0. It's probably impossible. That's why it's $1,000. No. Some $1,000 bounties are very possible. Oh, if you got fast Olmo and you want to merge that, there's a $300 bounty there too. If you can get 50% of the theoretical max. So I don't know if the speed ups are going there too. But yeah, being able to run MOE models fast is valuable to us. Cool. Anyone have anything else? All right, this has been Meeting 97. Thank you, everyone.